The special cases I want to look at deal with when you have a function that's just kind of hanging there and it never crosses. And if the problem gives you this function and it says, where is this function greater than 0? Well, it's greater than 0 everywhere because it's all positive. So that would be from negative infinity to infinity. Where is this function less than 0 or equal to? And that's the empty set. Doesn't exist. It's never going to be down here in the negative case. This one, if I have this function that just touches and just rests on the axis. All right, so I want to know, where is the function greater than or equal to 0? Well, it's going, less than, sorry. It's never going to be less than, but that equal sign, it is equal to at 1. So I'm just going to include 1. Even though it's never going to be negative, it is equal to 0 at 1. Now, where is the function greater than 0? That would be on this side, but you can't include the 1 because it doesn't say greater than or equal to. So then you get to do this little game with the negative infinity and the 1, and also from 1 to infinity. So it's very important that you pay attention whether it says less than or equal to, or just less than, or greater than, or just greater than or equal to. You have to pay attention to those. Now, in section 2.5, we talked about rational inequalities. Well, let's also work with those equations. And when you do that, you're trying to get the zeros of the numerator and the denominator. So you cannot get rid of the denominator, because I know the tendency here is to put 3 over 1, cross multiply, and make it go away. You can't do that. So you need to be very careful. I'm going to bring my 3 to the other side, because again, I want 0. So I'm going to have minus 3. Now that makes it less than or equal to 0. Now I know I need a common denominator. So I will go here and I'll say, all right, I need an x minus 2. So I'm going to make that x minus 2 so that I can combine those. Now remember, that's a negative 3 that I'm distributing here. So this is going to affect that product. So here, when we multiply that out, we're going to have x squared minus the x minus 11. This will give me negative 3x and a positive 6 all over my common denominator of x minus 2, less than or equal to 0. I'm going to combine terms, clean that up a little bit, and I get x squared. I have negative 4x's, and I have a negative 11 plus 6, so I have negative 5. All still over x minus 2. Now I can factor that beautifully, right? You're going to have x minus 5 and you're going to have x plus 1 all over x minus 2. Now again, look at your zeros of the numerator and the denominator. So your critical values are where x equals 5, negative 1, and 2. All right, so then you would set your number line, and you would simply put those numbers on there. Here's negative 1. I'm going to come over here. Let's see, that would be 0, 1, 2, 3, 4, 5. Okay, and it's less than or equal to. So I know that at those points it could be equal. So I'm going to circle, close those in just so that I remind myself. Now, less than negative 1, if I put a negative 3 in here, that would give me negative 8, a negative over a positive. So that would make a negative. Here, if I put 0 in there, I'm going to have a negative times a positive is a negative, divided by a negative, that's going to be a positive. If I put 3 in here, that's going to give me a negative, positive, so it's a negative divided by a positive, so that's going to give me a negative. And if I put a value greater than 5, 6, that would give me 6 minus 5, that's a positive, positive, divided by a positive. So now I can look at this and I can say, all right, I want to know where it's less than or equal to 0. That's going to happen in this area. So I write that interval. That's going to be negative infinity to negative 1, and it's a bracket at negative 1, or it's between 2 and 5. Now, you may think you're done, but there's a little bit of a problem because I put the critical values, I put those dots on there, but look over here. 2 is a critical value, but 2 was the one we got from the denominator. Can it ever equal 2? And the answer is no, because it's an asymptote. So this really needs to be a parenthesis at 2. Okay? So I usually run through, do that really fast, put all my dots on there, and then I go back just to double check. And especially on multiple choice exams, I could give you the exact same answer, but I could have put a bracket there, and you need to make sure you're careful with that. All right, one more example I want to set up.